let us start now. Our talk is the space environment effects. What are the challenges ahead? My name is Osama Shalabiea from the Cairo University and Bani Suef University, acting then at there. Let us start with the space environment, where and why the space environment is important. To build a spacecraft that will survive the harsh environment, we must first understand what hazards and what are the effects they may face during these missions, either equipment or materials, or even the human who goes to space in their missions. So if we use the satellites as a telescope, I mean space telescopes, then we try to study astrophysics, and we have to care about the environment that these telescopes or space telescopes is working on. Also, if the mission of the spacecraft is to use the application of space science, remote sensing, or communication, etc., there is another issue also to keep an eye for the space environmental effect. That's why a space environment is the most important in to start with design and manufacture and operate. It's not only for designing and manufacturers, but during the operation also of the satellites or the spacecraft mission, and operate more reliable, cost-effective for the spacecraft, either for government or the commercial sectors. As we know now, several companies started to invest in space, so their investments has to be taken into account for the space environmental effect. Of course, there is a natural space environmental effects that must be considered and related to the technology required. Here we can see clearly that the place where things happen is the space. For the first, the spacecraft orbiting the Earth, or if the spacecraft go to planets orbiting the sun, and the sun revolves around the center of our galaxy. Of course, the space around the sun and planets is that we are seeking and we are interested in for the interplanetary medium studies. Here we have that the space environmental and its effects in interplanetary space, because we have a very different kind of space from cosmos and the universe, galactic and intergalactic medium, etc. So it is defined by the solar wind, a continuous stream of charged particles emanating from the sun that creates a very tenuous atmosphere that we call the heliosphere for billions of kilometers into space. This wind has a particle density, of course, from 5 to 10 protons per cubic centimeter, and is moving at very fast from 350 to 40 kilometers per second. Here, what we can see from this figure, what are the parameters that affects the space. If we have this satellite, we start with first of all the gravity. Then we can has the effects of radiation. Then, of course, these satellites go in a vacuum almost, but not perfect. There is also a micrometeorites and the debris, plus all the atmosphere is a tiny atmosphere. So that what we have to keep an eye, plus the charged particles which accumulates on the surface of the spacecraft or affects the components electronically or material of the material of the satellite. So Earth, the sun, and the cosmic combined offers all of these offer unique challenges to spacecraft designer. Yes, it is a challenge, and it is one of the important parameter to start design the spacecraft, not only for that, but to make sure that the spacecraft keeps the mission objectives in its right and in the best output. First, the Earth's atmosphere. Of course, it has effect mostly on the low Earth orbit spacecraft, below 600 kilometer altitude, in two ways. The first, the drag, which shortens the orbital lifetimes, of course, and the atomic oxygen degrades spacecraft surface, and the spacecraft in orbits above 600 kilometers are fairly safe from these drags. Next is the vacuum, where the vacuum environment creates three potential problems. The first is the outgassing, release of the gassing from the spacecraft materials, then cold welding, that fusing together of metal components, the space between the mechanical components, and the third is the heat transfer, which limited to the radiation, not convection, neither conduction. If we go there to see what is going on in the space, we start with radiation and the charged particle. Three primary sources of these particles, which are solar wind, as we see here, and also the flare. Also, there is a galactic cosmic ray, which we have a parameter at last, the Van Allen radiation belt, which is well known. And here, just to know the size of this coronal mass ejection across the Earth, we can see that buoyant blue is the size of the Earth relative to that kind of harsh space environment coming out from the coronal mass ejection. There is not only that, but also there is comets that entering the solar system leave all this debris naturally, either or also the enter the asteroid belts between the inner and the outer planets that can also affect the debris. Here, that kind of debris in the space, and here we have some of the parameters that affected seriously the spacecraft, either during the design or manufacturing, or during its working the lifetime. Here is the thermal design, which we have also the materials that we have to protect from this harsh environment, drag, force, etc. So we have here the space environmental, either natural neutral atmosphere, sorry, and the thermal environment. The plasma also is one of the parameters that affect also meteorites and orbital debris. Here we can see how important to get precise as most as possible about the space environment by the mission since 1994 until now 2020, and still more to go in order to understand and to have as close as possible to the reality of the space environmental parameters that will help much to uh, design all the spacecraft missions based on these harsh environmental effects. I think the last mission was a solar orbiter last year to get as close as possible to our sun, our star, the sun, in order to understand what is going on and what all the parameters that can affect the space environment, to take all the cautions in this case. We have, of course, the solar wind, and we have also here the space environment. I am going to see this sun-Earth interactions. We all know these interactions is affecting the energetic particles from space with the electric and magnetic fields that also has its hazards on the of course, that the space environmental effects on the material of space missions are very severe and complex because of the synergistic interaction of orbital environments such as high energy radiation particle, as we have seen, atomic oxygen, micrometeorites, orbital debris, and UV irradiation interaction along with thermal exposure. Of course, we have the magnetosphere and space environmental effect. It's direct important to study the interaction of the solar wind with the Earth's magnetosphere, because these interactions control what we know space weathering phenomena. Then we have to forecast the space weather correctly in order to predict any events that may affect the space mission or spacecraft seriously. That can affect the satellite motion or its attitude control. The other indirect effects is coming on the ionosphere. Here, the questions we are raising, what are the questions and the challenging we are in this case, we ask, can we predict the arrival of solar disturbance to the Earth? The next question is, can we predict magnetic field velocity and other characteristics of interplanetary disturbance? Then we ask at last, can we predict the occurrence of flares and other high energy particles events, which would be the consequences of a superstorm on the present day technology? This all is still open questions, and we are in research. Every point has a team or branch research topic in open. Here we have to try to give an answer, since we ask these questions from the basic research in all space environmental aspects, that we need solar physics research, We need interplanetary medium to understand asteroids, comets, and meteor showers, natural space debris as well. Then we go to the magnetospheric, ionospheric, and atmospheric science. This is another very important branch. And at last, and also the most important, is the basic plasma physics and electrodynamics that can help us to study more the space environment, environmental parameter. To sum up, for the magnetosphere, what are the challenges? The Earth's magnetosphere is an extremely complicated system. We are far beyond completely understand everything that going in the Earth's magnetosphere. Second, it is shaped by the interaction between the solar wind and the terrestrial magnetic field. The basic components topology are, of course, the bow shock, the magnetosheath, the magnetopoles, the polar cusp, the magnetotail, and the plasma sheet. These are the topology. As we can see, each region needs still challenging to the scientist for more understanding. The point here is that there is in the open problem in the, for example, in the magnetopause, no rigid reconnection and will respond to solar wind. It will oscillate around its equilibrium state. More theoretical work in 3 dimensions is needed, of course. Polar cusps, how much of plasma found in the cusp has entered locally. This is also by what process and how much simple it is transit on its way from subsolar entry to the polar magnetosphere. A boundary layer, also global structure and topology. Going to the problem with the magnetotail, the ion composition, electron acceleration, how bursts of energetic electrons with relativistic energetic are generated in the magnetotail in association with the storm coupling between the tail dynamics and auroral phenomena. All this still opens and still needs more. In the magnetosheath also, there is problems that needs to be investigated. I think that I will go quickly to that issue with the space debris, a problem of all spacefaring nations that approach to dealing with the debris issue, scientific, technical aspect, international and national regularity frameworks must multilateral and potential initiatives to address this issue is also needed. Here we have one of the first certified victim of space junk or space debris, either natural or man-made, when its 6-meter gravity gradient boom was clipped off during the collision. This is one of the most important points. Dusty debris, this is also coming from the showers. What are the challenging here? That now the question is how to preserve the space environment for the future generation from more hazardous from these all parameters, especially the debris or the man-made. The challenges here, as we can see, is the increase of this man-made debris, especially in the gross population. This is one of the sheets, the figure that we...
Yeah, Professor, you have two minutes more.
Okay, I'm close by to the end. So the predicted population growth here, non-mitigations, projections average about the low Earth orbit, the mid Earth also geo. Here is can we see the dangerous of the exceeding number of objects greater than 10 centimeter with all the spacecrafts or the missions in the low Earth orbits. This coming from 1970, which is negligible or nearly none, to years 2020 or 2070 or 2050. That will be very dangerous, and we have to work on this. One of the challenges ahead is to preserve space environmental effects, as has become increasingly clear over time. Satellite, weather, and global communication installation and many defense systems have become dependent on the knowledge of the condition of the near Earth space environment. Therefore, I stop here and thank you so much for listening and your attentions.